Hi, thanks for listening. My name's Tyler and I'm a PhD candidate at the University of Miami working with Dr. Pakita Zaidama, and today I'm going to briefly discuss some work we've done diagnosing low-level dry convection over Angola in the beginning of the biomass burning season and how that's influencing smoke transport and offshore cloud radiative properties in June through early August. So what I've done here to introduce ourselves is I've plotted burned area overlain with local surface temperature maximum at 850 hectopascals, seen here in these blue contours. So even though we're in the austral winter, we see this large area of fires that's co-located with maximum and surface heating, also at this area of convergence between moist low-lying Congo to the north and elevated plateaus to the south. And if we look directly offshore, you see the annual maximum and cloud droplet number concentration. So something that we've always wondered is what are the exact mechanisms for smoke entering the marine boundary layer? And so we're sort of concerned from a process level because we know that when there's increased smoke in the boundary layer, you can get this cloud burn-off effect that's documented in previous literature, where smoke is reducing marine boundary layer cloud fraction, notably in July and August. And so we're going to characterize the vertical and also coincidentally horizontal transport. In a moment, we'll see through low-level atmospheric thickness, which is used in previous research to diagnose heat low strength. So what we see here is that in the afternoon, you have a relatively well-mixed boundary layer from the surface up to 700 hectopascals, and then the winds slacken, and then at nighttime, the boundary layer depresses and the eastward winds really pick up. So you also get the elements of a nocturnal land breeze that's in the monthly mean, bringing most of the smoke into the marine boundary layer. And we're going to composite weak or strong Angola heat low days, basically based on terciles of low-level atmospheric thickness. And then we're going to take meteorological reanalyses and series cloud properties during these regimes to understand what the Angola heat low's role is in the beginning of this burning season. So what we find is that when the Angola heat low is stronger, the continental high to the southeast of the region is also weaker, and the South Atlantic subtropical high is coincidentally stronger. So you see a well-formed stratiform cloud deck and reduced ND that's only sort of your maximum is only present right near the coast, and you see at 850 hectopascals the elements of that reduced continental high on the southern part of the continent. When it's weak, we get the opposite. So you have a reduced stratiform cloud deck, but a massive increase in offshore droplet number concentration, and that continental high, as you can see from these two panels, is much stronger and shifted to the northwest. You also see some of that increased subsidence above the cloud deck going on the southern end here around 20 degrees south. So these weak Angola heat low days are really when Ceres and ERA 5 say that there should be increased offshore smoke transport and reduced coastal cloud cover. So aerosol reanalysis also depicts a similar thing where during weak heat low periods, you have profound smoke transport off the continent and a relatively less smoky continental boundary layer, which we're denoting here with change in carbon monoxide. So basically that increased subsidence and easterly winds are blowing the smoke off the continent and also lowering the cloud fraction. We suspect increasing aerosol entrainment and aerosol activation in the coastal marine boundary layer. So because of this covariance between heat low strength and the South Atlantic subtropical high, smoke transport is at its minimum when the cloud deck is most well formed. The sensitivity is most pronounced in June. It decreases through August. And what you'll find is that even though droplet number concentration is decreased, the outgoing shortwave is increased because of these coinciding increases in cloud fraction and liquid water path. So even though the Angola heat low isn't seasonally established until August and September, what we found here is that in June, July, early August, it still has a profound influence on aerosol transport and co-varying cloud properties. So please feel free to contact me with any questions, and thanks for listening.